So when you have some interesting data to work with, probably you have inherited data from your workplace, from your company, what is the first thing you do with it? Where do you even begin your analysis? So this is what we're going to learn in this video today. So welcome back to the channel and welcome back to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. And today is day 65. We'll be consistent and we're not lagging behind on our learning journey. The goal is to complete this whole data analysis in Python career track on the DataCamp platform in the next 100 days. So we're on a new course called Exploratory Data Analysis in Python, where you get to figure out what to do with your data set immediately you have access to it, whether in CSV file, SQL database, or Jupyter Notebook files. What do you actually do with the data set immediately you have access to it? So this is what we're going to be doing today, how to get to know a data set. What you are going to do initial exploration, you're going to be doing some simple initial exploration, data cleaning and imputation, a relationship between the data sets, actually turning exploratory data analysis into action and actually begin your analysis. So this is broken down into 4 chapters. So the first chapter is how to get to know your data sets as a beginner or as the first time you're having access to that data set. So without further ado, let's get started and welcome back to the channel. If you're looking to see yourself in data analytics, I have a couple of live stream that I've been doing over the past 200, 300 days. I've done SQL, I've done Power BI, and I'm currently on Python. So I just go ahead so we can begin our exploratory data analysis in Python. Voila, let's go. So in this exploratory data analysis in Python, we have 4 chapters. So the first chapter is getting to know a data set. So what's the best way to approach a new data set? Learn to validate and summarize categorical and numerical data and create seaborne visualizations to communicate findings. So let's see, they will move to data cleaning and imputation. Probably we're going to be learning how to deal with missing data, addressing missing data, dealing with missing data, strategies to remain missing data, and so on, inputting missing data, plain prices, and so forth like that, and relationship with the data and turning exploratory analysis into action. So let's begin with the first chapter and see what we need to learn when we get access to an actual data set. What do we do for the first time? Okay, so I have my Jupyter notebook launched here. Just go ahead. So our data set for this. So our data set for this is going to be, hold on a minute there. Mm, I want to refresh this page. So I just go ahead and launch it again. Just a minute. My directory is not updating. I don't know why, so I'm going to figure this out later though. Okay, so let's continue from here.
Welcome to this course on exploratory data analysis. I'm Izzy, and I'll be your coach for chapters 1 and 3 of this course. My friend and colleague George will guide you through chapters 2 and 4. Let's say we've got a new dataset about books. Is this good data? What questions can it answer for us? It's only after we understand what our data contains that we can think about how the data might be useful to us. Exploratory data analysis, or EDA for short, is the process of cleaning and reviewing data to derive insights such as descriptive statistics and correlation, and generate hypotheses for experiments. EDA results often inform the next steps for the dataset, whether that be generating hypotheses, preparing the data for use in a machine learning model, or even throwing the data out and gathering new data. Let's begin by importing a dataset and reviewing some useful pandas methods for initial exploration. We'll import the books data from a CSV file using pd.readcsv and save it as a data frame called books. Taking a look at the top of the data frame using the head function, we can see that our data contains columns representing book names, authors, ratings, publishing years, and genres. Pandas also offers a quick way to summarize the number of missing values in each column, the data type of each column, and memory usage using the .info method. It looks like there are no missing values in our dataset, but it does have a variety of data types. A common question about categorical columns in a dataset is how many data points we have in each category. For example, perhaps we're interested in the genres represented in our books data. We can select the genre column and use the pandas series method .valueCounts to find the number of books with each genre. Gaining a quick understanding of data included in numerical columns is done with the help of the dataframe.describe method. Calling .describe on books, we see that it returns the count, mean, and standard deviation of the values in each numerical column, in this case rating and year, along with the min, max, and quartile values. Histograms are a classic way to look at the distribution of numerical data by splitting numerical values into discrete bins and visualizing the count of values in each bin. Throughout this course, we'll use Seaborn to explore datasets visually. Seaborn is imported as SNS. We'll also import matplotlib.pyplot, aliased as PLT. To create a histogram, we'll use sns.histplot and pass books data frame as the data argument. Next, we indicate which column we'd like to use as X by passing the column name rating to the X keyword argument. After running plt.show to display the plot, we see that most books received ratings above 4.4, with very few getting ratings below 4.0. However, the bin size here is a little awkward. Ideally, we would have a bin for each tenth of a rating, such as a single bin for scores greater than 4.5 to 4.6 inclusive. We can set a bin width of 0.1 using the bin width keyword argument. That's better. Let's explore a brand new dataset using these skills.
Okay. Now let's explore a burning data set using one of these skills. Just go ahead and launch my Anaconda Navigator again. So I can practice whatever I'm doing here in my own data environment. So it says functions for initial exploration. So you are searching on employment rates worldwide, and I've been given a new data set to work with. The data has been saved and loaded for you as a pandas data frame called unemployment. You've never seen the data before, so your first task is to use a few pandas function to learn about this new data. Okay, use pandas function to print the first 5 rows of the unemployment data frame. So we have it in there already. I just say unemployment unemployment dot head. Let's run the code. And voila, we have the first 5 rows right here. So print the first 5 rows of unemployment. As we have the country code, the country name, the continent, and the years. Probably record per year for each country. Interesting. So let's submit this. Use the pandas function to print a summary of the column, non-missing values, and data types for the unemployment data frame. Let me quickly launch my account Jupyter notebook here. So it to be unemployment.describe. Want to know the non-values? Oh, that should be unemployment.info. Gain information about the data sets. Just few seconds there. This is not fair. So what can I do? Wow, my file, I just loaded some new data sets and it's not seeing it. I'll just go ahead and create a file here. I want to try something first. And just create a new. I want to do something different real quick. This data set parts. Just create new notebook for this instance. EDA in Python. Let's just do that here. As you can see, I refresh now. So same thing I'm trying to do to refresh my page so I can have access to the data set, and I'm not seeing that. But that's by the way though. Let's make use of what we can for now. Import the libraries. So I need to read this CSV. I have a file, unemployment file in my local computer here. So I'll try to point to the direction. It's supposed to be a new folder here. I don't know why this is not coming up. This is not fair. Let's call it unemployment. So I'm gonna copy the file paths. So I've copied the file paths. Let's paste it here. The file path will be pretty long though, so I have to get rid of some stuff. Hopefully it's going to see it. Hopefully there won't be any error. As log and say I've created a new folder for this part though. I know why it is not seeing it. Let's run that. Error. Mm, okay. My error is coming from. This guy know where my error is coming from. Hold up. Okay. Let's troubleshoot this error real quick so we can continue. Just a second there. I want to read it real quick. Let's get help on that real quick. Yeah, I know I was missing something. So this is how you read a long file path Python. And to point the user out. So let's run it again. I'll read it like this for now. Voila. So that is solved. Ooh, how am I get an error again? Come on. Oh, I'm supposed to be having this here. Yep. That's why we are getting an error there. Perfect. So that's how to avoid using this longer file path. Refer that file. If that file has been in my that file path that I've created for this file path here, it is means there's a 10th folder here, number 10 folder I can see. Number 10 folder I've created that, but it is not seeing it. That's by the way though. Let's continue for now. Let's have to troubleshoot that real quick. So let's run employment dot head to see the first 5 rows. As you can see, so we have similar results right now, right? Similar to what we've actually done before here. So we have to read unemployment.info now. So the first thing is to print the first 5 rows of unemployment. So we already done that. Print the first 5 rows of unemployment. So we have the country codes, the country name, as you can see, the continents, the countries, and unemployment rates over the years from 2010 to 2021. So the next instruction now says, uh, use the pandas function to print a summary of the column, non-missing values, and data types from the unemployment data frame. So we know our unemployment is, data frame is this. How am I going back here? Unemployment data frame dot info to get those information. So let's say the same thing here. We're going to know if we have missing values or not. So put a summary of non-missing values. Let's run the code. So I can see we have non-null count. You can see we have the data type, objects, floats for each record. So float is 12, object are 3 here. We have no single missing values. This is 177. What does that mean? So 182 entries, 0 to 81, 181, data columns, total of 15 columns. 15 columns here. So we have 15 columns there. So let's continue though. So print the summary statistics, count, mean, standard deviation. That will be unemployment dot describe to get that information. So let's do that in my Jupyter notebook here, so you can have a better view. So you can see the describe. So it is counting, is the count of each column. So it's going to be describing the numerical variables here. Those are the floats record, not the objects column. You can see, so starting from 2010, 11, 12, 13, 14, 15, 10, 11, 12, 13, 14, 15. Here it is now. You can see 16, 17, 18, all the way to 2021. So it's giving us the mean, this S standard deviation, minimum value, the 25th, 50th, 50%, and 25th percentile, and the maximum value in each column. So excellent work. You've now learned that unemployment contains 182 rows of country data, including country code, country name, continent, and the unemployment percentage from 2010 to 2021. If you look very closely, you may have noticed that a few countries are missing in the continent. So as you can see here, I said it earlier, a few countries are missing in the continent. You can see we have 177 records from the continent column, and the rest of the columns are 182 records. You can see, so that's how you know that, you know quickly at a glance that your data is containing some missing values. May contain some missing values rather. So let's continue. Counting categorical values. Recall from the previous exercise that unemployment data frame contains 182 rows of country data, including country code, country name, continent, and unemployment percentage from 2010 to 2021. You would like to explore the categorical data contained in unemployment to understand the data that it contains related to each continent. So the unemployment data frame has been loaded for you doing along with the pandas PD data frame. So use a method to count the values associated with each continent in the unemployment data frame. So I want to count the values associated with each continent. So I'm going to say unemployment. So that's our data frame underscore value count. Let's run the code. Oh, each continent. Oh, so I have to mention uh unemployment dot value count. I mention the continent column. The column I want to perform value count on. Value counts. There has to be an S there. Better. So now let's see it in action. It's not quite clear. I could actually make it clearer. So you can see the continent column has Africa in the record. Let's do it here. So the column continents has this record. Africa 53 times, Asia 47 times, Europe 39 records, North America 18 records, South America 12 record, and the Oceania 8 record. So the categorical variables that we have here on this continent column. So this is the number of record that we have there at a glance. Well done. Did you know that there are 23 countries in North America, which includes countries in the Caribbean and Central America? You may have noticed that North America has 18 data points in the unemployment data frame, so we are missing information on a few of the countries from our data set. Because North America has 18 data points, and there are actually 23 countries in North America. So this is where our missing record is coming from. You get it now? Based on the continent column that we looked at here. You see. So if you know that there are a certain number of countries in North America, you are missing record for some country here, so we can deal with the missing data from that column. Oh, great. I'm trying to get back to my learning spree. So global unemployment in 2021. It is time to explore some of the numerical data in unemployment. What was typical unemployment in a given year? What was typical unemployment in a given year? What was the minimum and maximum unemployment rate? And what did the distribution of the unemployment rates look like across the world? A histogram is a great way to get a sense of the answer to these questions. The task in this exercise is to create a histogram showing the distribution of global unemployment rate in 2021. Okay, let's show the distribution of unemployment rate in 2021. Do I have pandas imported here? So I have pandas, I have matplotlib as PLT, I have cborn as SNS. Let's import cborn as SNS. So I want to use histogram to show some record there. A distribution of unemployment rate in the year 2021. So it's sns.isplots. So our data points is equal to the unemployment variable data frame, and the column we want to use is year 2021, column 2021 from our record there. Let's run the code and see. Ooh, I have PLT twice there. Uh-oh. Cborn. Did I spell my cborn incorrectly? Attribute module cborn is not attribute is plots. East. Oh, my plot should be east plot, not east plot of Ola. So I can see it. So let's look at it better in Jupyter Notebook. So run the code and voila. You see the unemployment rate for 2021. Mm-hmm. And let's submit our answer. Oh, I need to add the bin width again. So import the required visualization libraries to create a histogram of the distribution of 2021 unemployment percentages across all countries in unemployment. Show a full percentage point each in each bin. You have to reach a bin method there. So you have to add bin width here. Bin width. Bin width should be equal to 0.1. Let's copy and try it out here. That's super tiny. Or the begin with should not be 0.1. Let's submit and see first if we actually get it. So expected 1, but got, so it's supposed to be 1.1. Voila. Let's do 1. Voila. So you can see the beam width now is 1. And look at the difference. So nice work. It looks like 2021 unemployment hovered around 3% to 8% for most countries in the data set, but a few countries experienced very high unemployment of 20 to 35%. So you can see, so most of the countries, the unemployment fall between 3% and 4%, or what did you say there? To 8% rather, 3% to 8%. So from here, so you start getting high unemployment rates from 3% to 8% for most country, and it went down here. While some countries actually experience 35%, but let's see that unemployment as high as 20 to 35%, as 20, and some countries there as 20, 25%, and it's also dropped back again as 20, 2029, 28%, then 35%, it dropped down. But probably one or two countries, and the count is low, probably one or two countries, you need is 35%, 30 to 35% unemployment rate. That is super high for a country to be having that much percentage of unemployment. Let's see. Let's continue. Okay, now we've used our skills to analyze that. So let's do something, some data validation again. We still have like 30 minutes more to go.
Data validation is an important early step in EDA. We want to understand whether data types and ranges are as expected before we progress too far in our analysis. Let's dive in. We learned in the last session that .info gives a quick overview of data types included in a dataset, along with other information such as the number of non-missing values. We can also use the dataframe.dtypes attribute if we're only interested in data types. But what if we aren't happy with these data types? Here, the year column in the books data frame is stored as a float, which doesn't make sense for year data, which should always be a whole number. Luckily, the .asType function allows us to change data types without too much effort. Types. .dtypes attribute if we're only interested in data types. But what if we aren't happy with these data types? Here, the year column in the books data frame is stored as a float, which doesn't make sense for year data, which should always be a whole number. Luckily, the .asType function allows us to change data types without too much effort. Here, we redefine the year column by selecting the column and calling the .asType method, indicating we'd like to change the column to an integer. Then, we use the .dtypes attribute to check that the year column data is now stored as integers, and it is. Common programming data types, as well as their Python names, are listed here. It's the Python name that we pass to the asType function, as we did with int on the previous slide. We can validate categorical data by comparing values in a column to a list of expected values using .isin, which can either be applied to a series, as we'll show here, or to an entire data frame. Let's check whether the value in the genre column. We can validate categorical data by comparing values in a column to a list of expected values using .isin, which can either be applied to a series, as we'll show here, or to an entire data frame. Let's check whether the value in the genre column are limited to fiction and nonfiction by passing these genres as a list of strings to .isin. The function returns a series of the same size and shape as the original, but with true and false in place of all values, depending on whether the value from the original series was included in the list passed to .isin. We can see that some values are false. We can also use the tilde operator at the beginning of the code block to invert the true-false values so that the function returns true if the value is not in the list passed to .isin. And if we're interested in filtering the data frame for only values that are in our list, we can use the isin code we just wrote to filter using Boolean indexing. Let's now validate numerical data. We can select and view only the numerical columns in a data frame by calling the selectDtypes method and passing number as the argument. Perhaps we'd like to know the range of years in which the books in our dataset were published. We can check the lowest and highest years by using the .min and .max functions, respectively. And we can view a more detailed picture of the distribution of year data using Seaborn's boxplot function. The boxplot shows the boundaries of each quartile of year data. As we saw using min and max, the lowest year is 2009 and the highest year is 2019. The 25th and 75th percentiles are 2010 and 2016, and the median year is 2013. We can also view the year data grouped by a categorical variable, such as genre, by setting the Y keyword argument. It looks like the children's books in our dataset have slightly later publishing years in general, but the range of years is the same for all genres. Now it's your turn to validate the unemployment data.
Okay, now let's use what we've learned to validate the unemployment data. So the 13 data types, super simple. We're going to use .dtypes, determine the data types, the types function. So a column has been changed in the unemployment data frame, and it now has the wrong data type. This data type will stop you from performing effective exploration and analysis. So your task is to identify which column has the wrong data type and then fix it. Okay, now let's discover the column with the wrong data type from unemployment. Let's see. Let's run the code. Oh, how do I determine that if I can't do that? It's also available. Oh, I'm putting the wrong. I'm not supposed to put that there. Sorry. They say which column has the wrong data type. Let's see that in here also. So unemployment, body types. Let's see. All these have objects, the country code, country name, and continental all objects. Okay. Then the year column are all floats. The year column containing the percentages of the unemployment rating are all floats. You just say the year columns. These columns are have the wrong data type. Data type object in signature type self. Okay. Dog string type name. Okay. Now let's answer the question: which column has the wrong data type? Should we say the country code, which is having objects, the country name? Which of the following column below requires an update to its data type? Mm, we say country name, say country code, data type is objects, country name, objects, and And we also have the continents as objects. All these are objects, which is correct. So all these are integer. So we can't guess which one is that's the wrong data type. Just double checking. Mm. Now let's see. It's quite tricky though. Sync data. So are you telling me this 2019 is float 64? Oh, I didn't pay attention. Take a look at this. When you look at 2019, let's go back here. 2019 here. Oh, I'm looking at it wrongly here. Mine is clean here. You can see. My data type is clean here. You can see all the column with the years are floats. You can see. But when you look at take a closer look here, the 2019 year is objects. I didn't see that real quick. So determining data types, since my own data types here are correct, so there's no need for it to be updated. I'll just go ahead and update this one here. A column has been changed. Okay, you update the data type of 2019 column of unemployment to floats. Just say unemployment 2019, then unemployment 2019, and the year also. Let's copy this here. Dot class type. Then we mention I want it to be floats. Then put unemployment dot the types on the code. You can see now it has been updated. Okay, thank you for that. Now, validating continents. So your colleague has informed you that data on unemployment from countries in Oceania is not reliable, and you like to identify and exclude these countries in your unemployment data. The isIn function can help with that. Okay. Your task is to use isIn to identify countries that are not in Oceania. These countries should return true, while countries in Oceania should return false. This will set you up to use the result of .isIn to quickly filter out Oceania countries using Boolean indexing. Interesting. Okay, now define a series of booleans describing whether or not each country is outside of Oceania. Call the series not Oceania. Okay, we need to define a series not Oceania. Okay, we need to define a series called not Oceania, which is going to be equal to unemployment unemployment continent column, the continent column dot is in. So how do we mention if the country is not in Oceania? Each continent is outside of Oceania. Okay, hold up a minute. Let's take a closer look at this. You can see there's continents, Oceania here. Okay, not in Oceania. Unemployment is in. Hmm. Let's take a deep breath. How do you figure this out? Okay, those that are not in Oceania, we're going to return to. So what I'm basically doing is looking at the country column. country name that are not that is not having the continent Oceania. Oh, interesting. It's supposed to be outside of Oceania. Each continent is outside of Oceania. Okay, to do this, your task to use is in 25 countries that are not in Oceania. So countries that are not in these countries should return to while other. Hmm. Okay, it's going to be country, the country column. Let's see how we can do it. Country underscore name. Underscore is in. And let's see Oceania. Let's see if we actually got that correctly on the code. Ooh, there's an error somewhere. Let's see. Let's get up on the error. So the error is coming from continents. Okay, so it's supposed to be continents. I want to filter on country. Okay, well, let me get back. Let me get my continent back. I want to filter the country out. Oh, I'm not wrapping this in square brackets. This will still be in square bracket, even though it is one. Okay, okay, okay. We've defined the series. Let me try it here also. Define a series describing whether each continent is outside of Oceania. Okay, now if I run this line of code, I'm going to see true or false. You can see false. So those that are not in Oceania return false. The column that is in Oceania, you can see, is true. So 177, which is this one here, this record there in continents, there are certain record there. Okay, now it's starting to make sense. Now let's submit. Oh, did you return a Boolean series of continent value that are not associated? Did you see? Okay, oh, that was the error. Mhm. You find a series of Boolean describing whether or not each continent is outside of Oceania. Call this series not Oceania. Okay. Hmm. What's the error coming from? Come on, come on, come on, come on, come on. I'm writing it's the same thing now. Example of using is in and have you considered using the is in method to check if the continent are in a specific list and then using this operator to invert the Boolean series? Okay, do you want me to invert the Boolean series? What is this operator? Ooh, there's an error there. Can I assign the expression here? Maybe you mean mm, mm, let's see. So there's an error somewhere. Oh, it's supposed to be here. Okay. So what's the difference between this and this? Let's see the difference between this and this. This returns same result too. Make it not in Oceania too. So I have the different results. This is returning the true first, while this is returning the false first. Okay. So all these are not innocent. So the truths are coming up first here, followed by a false. Okay, now let's continue and see if you're actually absolutely correct here. Hmm. Use Boolean indexing to print the unemployment data frame without any of the data related to countries in Oceania. Okay. Now we're going to use the Boolean indexing to print the unemployment data frame without any of the data related to countries in Oceania. So we don't want countries in Oceania to come up. So we're going to use not in Oceania this time around. So in the continents, so I say in this continent column, exclude countries that are from Oceania. That's what we're simply saying here. Let's do that. Let's see how to do that. Okay, not Oceania. We have it already. Print unemployment without records related to the countries in Oceania. Unemployment without records. Okay. Yeah, do we do that? So I'm giving it a shot. So it's going to be unemployment dot eh, let's see if it's going to work. Dot edge. Let's go. Ooh. What's the best way to log that with it? Going to be unemployment. Let's do it properly using indexing. Then unemployment. Then we want to mention D without countries. The continent column. Let's go for the continent column. Okay. Hmm. So I'm still missing something here. Unemployment. Continent column, not in Oceania. Dot edge. Ooh. Okay, let me get up on the error. I'm actually closer. So I'm just missing. Oh, I'm missing my. So I cannot use the. Why is this not creating the variable? The series in the first place. Since I still have to use this method. I think if I have this, I don't need to use this method. Okay, unemployment, continent is in. Oh, come on. What's the essence of it creating this Boolean series in the first place? This is what we've done here. So we just printed the record. Now let me copy this out and try it here. Hmm. I'll just make it easier. So if you look at the countries, let's say dot edge, you can still include dot edge here. Let's see, it's going to work. Mm, It's not going to because of the closing parentheses here. Oh, let's see. So country, continents, so it's printing continent, Africa, and so on, and excluding those from Oceania. Because 174 rows of data and 15 columns instead of 182 rows of data. Now let's see, we still need to practice this more. Well done. You validated the categorical data and use your is in validation to then exclude data that you weren't interested in. Filtering out data that you don't need at the start of your EDA process is a great way to recognize yourself for the exploration yet to come. Interesting. Okay, see one more thing, one more challenge to solve here. Validating the range. Okay, now it is time to validate our numerical data. We saw in the previous lesson, using dot describe that the largest unemployment rate during 2021 was nearly 34%, while the lowest was just above zero. Your task in this exercise is to get much more detailed information about the range of unemployment data using seaborne box plots, and you also visualize the range of unemployment rate in each continent to understand geographical range differences. Okay, print the minimum and maximum unemployment rate during 2021. Minimum and maximum unemployment rates in 2021. Interesting. There's going to be unemployment in 2021. So it's kind of specific also. In 2021. Mm, in that order, in 2021. Okay. Let's see how we do that. The best way to do this. Let's look at what the year columns look like in 2021. Okay. So our column is 2021 column. unemployment data frame, twenty 2021, 2021 dot mean, and this will be dot max. Okay, create a box plot. I'm going to create a box plot of 2021 employment rate broken down by continent. Okay, XNS dot box plots. Our data is going to be unemployment, and our x variable is going to be 2021, and our y variable is going to be by continent. Continent. Now let's see. Voila, we're on track. Okay, just copy this and give it a shot here. That's what we have here. Because this is the minimum and maximum unemployment rate in 2021. If you have a box plot, this is what the box plot is showing us for the unemployment rate in 2021 alone. You could see there are some outliers here, having close to 30% unemployment rate in Africa. This is the mean. This is the first quarter and second quarter. Interesting. Now let's continue and see what we have here. Nice work. Notice how different the ranges in unemployment are between continents. For example, Africa's fifth percentile is lower than that of North America, but the range is more wider. 50th percentile is lower than that of North America. You can see. So the fifth percentile is referring to the mean here. Ooh, this is a lot of EDA in 1 hour. Interesting. Because we're actually answering a lot of questions and trying different stuff. I think that should be the end of the live stream for today. We are going to continue from here tomorrow. So we are going to move into data summarization by tomorrow. Alright, so that will be the end of the live stream for today. So if you found value in this learning journey with me on Python, do want to support the channel by giving the video a thumbs up, hit that subscribe button, and I'll see you on the next video on the channel. Have a wonderful rest of the day, and bye for now.